and welcome to another exciting session of the course Data Analysis using Python. So earlier we spoke about how to set you up. Basically, we said get yourself an IDE, right? So an environment setup IDE, as you've come to learn, it's an acronym for something. Okay, basically an environment. What you would use to execute the codes or scripts that you'll be writing in the Python language. So it's good that you get yourself something you think you'll be familiar with, or something that your local machine can easily run with some demand huge resource from the computing device. So I use VS Studio. Okay, there are several others out there, and so that's why I wanted you to just select what works best for you. And on VS Studio, I'm using I'm not writing a .py file, I'm writing a notebook file. Okay, so all of these are subjective. Okay, but let's just get into the core of it. So the core of this is using Python as a tool to analyze data. So first, we need to understand the language of Python. Python is basically like a language. Okay, so we need to understand the language of Python, and then we now have data as we know it, and we use the Python to analyze the data. So the first thing is, in the language of Python, just as you would interact, say you walk into a grocery store, or you try to purchase something, there's a currency you're paying with, right? So it could be USD, pounds, euro, or in my case here in Nigeria, we use the naira as a currency. Now, all these are in terms of currency as a type of I'll just use the word data type, because we're talking about what I want to explain is inbuilt data types of Python. Okay, so we have different currency types. You could say the dollar, the dollars, the US dollars, Canadian dollars, any of the dollar types, or the Nigerian naira. Okay, you can also search about that. Nigerian naira, I tend to transact with that a lot. That's the currency of my home country. Okay, so similarly, Python also has what you could say a currency, and so different currencies, as you would have it, different data types. It's important to understand these inbuilt data types of Python, because this forms the basis of you interacting with things in Python. So these data types are what we also would call variables. Okay, so how you store, because the variables, if you recall from your earlier arithmetic classes, is how you store values. And storage here, speaking of data. Okay, so we have different types of data, just like you would have different kinds of currencies. So we have numeric data types, we have data types that deal with like text, non-numeric, and it just goes on and on. So let's talk less and let's write a bit more. So for the numeric data types, we know they are whole numbers, just a complete number. Like I'm just going to just type out 87 here, that's a complete number. Now 87 and 8.7, or still on 87, I say 87.1. They're not the same. Okay, so one is just 87, a complete whole number, and one is 87.1. It has a decimal place, or decimal point, and just one decimal point. Right, so that's two decimal points, three decimal places, as the case may be. Now, how are this type of data stored? How does Python interpret it? There are terms that we need to get familiar with. So for the whole number such as this, it's seen as an integer, but it does not display it as full, the word integer, int, and it goes on. It's just a short word to say int, okay, as an integer, or you could also say as an int. Okay, now that's what this would be. So if we were to just give this, say num1 is equal to this here, and num2 here if I were to pass a value to it, okay, and I'm just saying, I'm just giving this a value of num, a title of num2. This first one is an integer because it's a full number, right? Now the second one is not a whole number. It has decimal places. Now we don't refer to it as decimal places in Python language. We refer to them as floats, numbers with decimal places. So if it make it easier for you to understand, say the decimal places means that other numbers, attached to the main one after the decimal point that are floating. I'm not sure if that was the real intent, giving it that name, float, but that's how it's interpreted to the machine itself, as a float. So you have the full number is 7 and NUMT, which we are just saying, NUM2 rather, which we are just passing as storing under this variable of num2, right, as a float. Now that's for numbers. Now what about for non-numeric data types? So we could say a text like my name. So what's my name? Right. So I'm just going to say my name. Okay. Pass it in here. Now for this, it says it's already completed. So my name is Belema, right? And so I just have that, but it's in quotes. Okay, so double quotes, single quotes work. In some cases I would even advise you to use double quotes, but single quotes works just fine. But what's very important to understand, to know, is this value stored in this variable, my name, is not an int, it's not a float, it's a string. Okay, so a string basically, I like to call them text. It's a non-numeric data type, and you could express it as a text, you could express it as alphanumeric. So we could create another one to just say my code. Say you have a special coupon code for this course, and I'm just going to say yours is BG12778. Yeah. Right. Now this is also a string, okay, because it's not a number. It can be interpreted as a number. You can perform arithmetic operations with it. Okay, so it's not a number. It's neither an int number type, neither is it a float number type. It's a string because it's a text. So it's just combination of different things that is not a number. It's a string. Okay, now you see more of this, you appreciate more of this as we progress. Another popular thing, which at this point I would just like to also quickly point out, is while we've not delved into functions as a thing with the Python language, it's good to just know this simple operation, basic operation. It's one easy way to troubleshoot. So to troubleshoot is basically like you're trying to see what are a very quick tip I just like to add is, for the purpose of troubleshooting. So troubleshooting within this context, and perhaps any context, is like trying to figure out something. So you're just trying. It's like you're testing. You're testing to see what could have gone wrong. What can I tweak to just remedy it. So that's one way of thinking about troubleshooting. So, you try to turn on your car and it refuses to come on. So probably want to check certain things from the dashboard lights. If it feels okay, you want to pop up your bonnet to check if your battery terminals are properly connected, to see if you have enough petrol. You could go to check the plugs, things like that. Okay, that's you troubleshooting in terms of a car. So you think about it, even your phone, it's not coming on, or perhaps it's acting funny. You may want to just check certain things like, is it properly charged, and things like that. Those activities, those are troubleshooting tasks. So one very fundamental way of troubleshooting things in Python, the Python language, is to use a print command. Okay, it's actually a function, but the print command. So with the print command, what you're doing is basically to just let the computer say something back to you, to return something back to you. So it could be a literal text, such as this is a test here, and I'm going to just run this. Okay, so I'm just going to run this quickly, and so you can see that it outputs this is a test. Now I and that's because it's a string. Now I could pass num1, okay, in here. I say this is a test, and it gives me returns the value of num1, just to be sure of what we did. So like I said about, I just explained about troubleshooting. So one way of troubleshooting in Python is to use a print command. So the print command, with the print command, you're basically trying to check for things. Okay, so just like you would check to see, oh, is my phone properly charged? Is the car battery, the terminals, are they properly fixed, and things like that. So you could also just return a string to say this is a test. I run this, and you see that value just returned to say this is a test. Now put comma, just so you could add another value. I'm going to say num1 just for testing purposes, so you can see num1 there. Okay, and you see this is a test, and you see the value of num1. Now if I want to see the type, okay, so I had mentioned uh, integer, float, right? But I want to be sure of the type, so I could have it pass the type to me. So I'm just going to run this. Say this is a test, and I see the type for num1, right? Int. For num2, you can see float. And for the third and fourth variable, which is my name, my codes, you can see that it has the type of a string. Okay, it's a class, they're all classes on them, but more importantly, that I want you to just focus on at this point is this int float str, which is short for string, right? That's what I want you to just really focus on at this point. These data types, inbuilt data types of Python. Okay, of course we're going to build more on this. Okay, when you're saying this word class, we're going to talk more about classes as we progress. So now you've seen three data types. You've seen the integers, the int, the int. You've seen the float. So we've said the float, as you can see, they are numbers with decimal places, as you know it. And so we also have strings, which are basically text. So they could be alphanumeric, or they could even be just alphabets to read. But the key thing is that they are enclosed in quotes, single or double quotes. So there are other variable types. Okay, so there's the Boolean variable type. So basically, the Boolean variable type, excuse me, is just has two forms. It's either it's true, which you can see here, or it's false. Okay, and if we're to just continue with this check here, and I say type, which is what I pass BLN, the name of the variable there. I can see that you can see here bool, BOOL, an abbreviation for Boolean. Okay, so Boolean, for Boolean data types, there is binary, so it's either true or it's false. There's no in betweens. You would also get to see when to apply these different data types or variable types as we progress. In addition to this, there's still a few more I want to speak on. Now, as we're progressing to different data types, so this is part of where it gets tricky. It was also a bit of a, like say, a head scratcher, trying to familiarize myself with this or draw a distinction between this next set of data types. So we have numbers, different the number types, and there are more variable data types. There's another type of numbers which are like complex numbers, which we don't have to get into at this point. You can always look that up. Okay, and on this channel, one of the things we encourage is self improvement. Okay, sticking to the part. Okay, the next data type speaks to items in lists, so they're like a list of items. Think of it like you've just gone shopping. Okay, so things that you've bought, you rarely buy just one thing from the grocery store. You want to buy like a couple of things, so they're in a list. So for me, in my earlier years, my mom would sometimes just write on a piece of paper things for me to go get at the market or at the nearby supermarket, and I would try to stick to that list. So I just look at the list and I say, hey, I want this, I want this. And in some cases, the store owner would just ask me, maybe perhaps out of impatience, like, let me see that, right? So he can confirm that what is on the list is what he or she has to provide to me. I don't know if it sounds familiar. Even if it doesn't, this is why we're here. So there are different data types that speaks to things in the list, and you would also get to see how you could come to use list while exercising yourself using the Python programming language. So the first is the word as it says list. Okay, list, and so we have list. Luckily, I'm just going to say first list here, and we have just a list of numbers 1, 2, 3, 4, 5. Okay, and there is another type. It's called a tuple. Okay, I'm just going to say first tuple, and you're saying 1, 2, 3, 4, 5. If I were to ask you, looking at these two, can you really see something to say that this is different from that this first list variable is different from this other one? Now, of course, if we just move over here to look at the type, okay, to look at the type, we would see the type, okay, we'll see the type all listed here. So we have list and we have tuple. But what is the main difference? A quick eye test would show that they are both enclosed in what looks like brackets or parentheses. However, the bracket types are different, and it's a good way to start off with the distinction, okay, before we get a bit technical. That for a list type, right, a list type here, it's enclosed in square brackets, okay, it's enclosed in square brackets, while for a tuple, it's enclosed in the popular brackets, parentheses. I don't know any other technical term that you would ascribe to this symbol. But more beyond symbols, a main distinction between a list and a tuple is that one is editable and one isn't. The actual term is one is mutable and one is immutable. So to say something is immutable is that it can't be changed, it can't be altered, and that's what a tuple. So the one that has this normal bracket symbol, the parenthesis, the tuple, it cannot be altered. You can't add another value to this variable here, right? However, for the list type, the list data type, you can add more things to it. So if we walk back with the scenario I was trying to posit to you in my younger years, working with a list that my mom, had shared. If I was asked, and part of what she has written there on the list was get powdered detergent, and I get to the store, there's no powdered detergent. All it has is liquid soap. Knowing that they both serve some basic primary function, right? To perhaps to do laundry, or let's just use the generic term to say that they are both cleaning agents. Now, do you think the store owner can alter that to say, okay, take, why don't you just take this, right? Take the liquid soap. There's no powder detergent, take the liquid soap to save you the hassle of having to come back. I think your mom is going to need that. If he does that, what are we going to call that? He has altered the list. So that would be what we have in the first one here, the list type. But in a case where the store owner is not familiar with me, okay, he simply just says there's no powder detergent, okay, and at that point I do not, especially in my younger years, I did not usually have the autonomy, especially when I was not told like if this isn't there, get this other one. So when I don't have that autonomy and there's no existing relationship with the owner of the store there, that particular, I'm trying to avoid using the term list, stays that way. It's not altered. That is what we call a tuple. I really hope this makes sense. You can just give it a second, for it to just settle in, play it again. Sometimes it takes something, some concepts do not just come in at once. Sometimes you need more than one try to get it up. Okay, so just if you don't get it at a go, take it easy, breathe, play this video again. Okay, and where you're not clear, you can simply drop your questions. But the thing you need to know, like one of the major distinction factors between a list type and a tuple, is that for a list, it is mutable. You can edit, you can add, you can remove, you can alter. Okay, so that's what makes it editable. The actual term is mutable. Okay, whereas for a tuple, which is in normal brackets, the curve as we know it, it is not editable, it's immutable. So that means you can't add to it, it's immutable. You can't change, you can't alter the content of a tuple because it's immutable. So you think of when you want to use this as a data type, as you get to use the programming language, for things that you just want to be closed in, you don't want access end to end, it's just closed the way you've set it. That's how it should be. You can use a tuple when it's a list of things. And then for things that, oh, you want input, you could use a list type. Okay, just take it easy. If it's not coming all coming together, it will, right? No pressure. So let's look at one more data type. Okay, just one more data type. It's not too much yet. Just one more data type. So the next data type we want to look at is still like a list, but here, yeah, in if you take a look at this, it just has items in the list. Now, in both the list and the tuple, items in the list. And how do we make reference to these things? Now we use numbers. Yeah, we could also use different, could use text, okay, which is, say, we could use a string. So I could say Belema as my first item here, and I could put a number as 11. I could go to say big big stuff, they spell that right, big stuff. And what else? We could just do different things, okay, and this is still very valid. Okay, this is still very valid as as a list. Okay, similarly, if we wanted to do something about a tuple, okay, so we could also do same thing for a tuple, and they are both valid. And if we call them, so I'm just going to call them here, with the print, to say I want you to display the second list, the second tuple. Okay, and I just hit that, so we can see. So this is the first list, the list rather, and you can see it in square brackets, and then you have the tuple in the normal brackets, as you know it. Now, one of the things I wanted to just quickly point out is the way the items are listed in a list, in a list, they are is you can reference them based on positions, and that's what I did there, based on positions. So what do I mean by positions? So let's look at the first list. We have numbers 1 2 3 4 5. How many items are in this list? You were going to count same way, 1 2 3 4 5, but thankfully we have these ones here, that have different data types in them. Okay, so you see that a list and a tuple can also hold different data types. Okay, bear that in mind, because what is basically carrying it is a list, so it's just like a platter, or your cart in the grocery store. You could have different things in your cart in the grocery store. So if we were to count in the second list, how many items we have? We have 1 2 3 4 5. Now, if you want to reference, so you don't want everything in the list, you don't want everything in the tuple, you could say, oh, I just want the first item. That's where the next trick comes in. The way we count it, we don't count the first character or the first element of the list or the tuple as one, based on the position. The position that is assigned to the first element is 0. The next element is 1. So while just looking at it as a normal human, which you are, you would say one, Belema is first item, this is second item. But to make the computer understand it, the position of Belema here is 0 and 11 is 1. So if I change this here now to say 1 and I run, what do you expect to be outputted here? I'm going to just take this off here now. I'm just going to take this off, and I want to make sure everyone's on a fresh line. Let's just excuse me. Okay, so we can see this better. Great. Yes, I can see it too. So on this bit, let me comment this. Let's just comment this out so we don't have to really do anything about this. And commenting now, that's another thing. Okay, so that's just another thing which we are going to talk about later. So let me run this now, and you can see from the second list, I said I passed the position of 1, okay, and it returned Belema. Now, if I ask you, what should I pass in here to return the value of 19.5? Okay, just 3 seconds to guess on, or 3 seconds now is 0, 1, 2. I gave you a clue there. I gave you a clue. So what value should I put in there? That's what I did. Okay, so we see that the value outputted here is 19.5. So you understand the logic of referencing items in a list or a tuple is based on positions. Okay, so and the position you start by referring to 0 as the first item. So where you have Belema here, it's 0. So even if it was a different name, okay, so a name like Grand, and I want to reference Grand, what would I pass in here? I would pass in 0. Okay, I'll pass in 0 and have Grand outputted in here. Okay, I'm just going to give you a second to just breathe in and let this sink through. Okay, go back, and the next data type still has a list. I want to quickly look at is dictionary. I'm going to give you one take-home quiz, okay, for an idea type which I want you to look at. So you can just write it down. Set, okay, set. So look, read up everything you can about sets, and where you're not clear questions you may have, please share, and I'll be excited to jump in on that. So now the next data type I want to speak about is dictionaries. So for the list, the only way we can reference items in a list is through their positions. But there are sometimes where you would wish, just like let's still fall back to that younger Belema that went shopping based on the list his mom gave to him. So my mom didn't just write cleaning agent and stuff like that. Yeah, if it was to the market, she would write things like meat, she would put an amount. Fish, she would put an amount, She should put something, like the item and put an amount. In this context, you could say that item is or was a label. Okay. And that's one of the areas where dictionaries really come in handy. Okay. We'll speak more about that just at this initial phase where rather than just say, oh, what if you don't remember the position? What if you don't know whether it's on one or it's on two? But you're very sure that it's the first name. So I'm just going to write our very first dictionary. Okay, our very first dictionary. And the way of writing a dictionary is the basic way of writing a dictionary is to use curly brackets. Okay, so I have 30 cents already running this. So we have curly brackets and the labels. So the labels are the first things. Now I'm using the word labels. The actual technical term is keys, because just the same way the list and the tuples work with positional values, so God said this is 0, this is 1 based on the position. For a dictionary, it's working with keys. So each key has a value, just like that imaginary list young Belema used to go with to the market. Okay, so the key of the meat had a value of 5,000, and I think I should just include that in here. Please don't tell my mom you saw this. Okay. So I'm just going to say meat, right? And I'm going to put the value. So meat, so the key, you have to include it in quotes, as you can see, a column, and then the value of that key. It could be an integer, it could be a float, it could be a string. Okay. It could also even be a list, but in this case here, I'm just going to pass a float and say 5, 0.5. Okay, and that's how I'm just going to leave this at this point and close this. Okay, now I can reference it by position, or I could, you know, I could just call this first list here based on a key. So key that I want to use here now is meat. So let's see what happens. There's an error with that, so I'm just going to say it's okay. Still an error with this. First, oh, I'm calling the wrong. So you see, I'm calling the wrong. It's dictionary I wanted to call, not the not the list. So I kept referring to dictionary. But what I wanted to call was of the list, right? What I would call was, so I'm just saying what I want to call here now is meat. Right? So I do this and I can see that the value for the that meat is returned. Okay, I bet this is a whole lot easier than using this one of positional arguments. You could still use positional arguments for your dictionary, but where you're setting of the key, you know, the key, I'm just going to use that, the key or the label, say, oh, what's the value of the meat? So meat in that list. So it started off as a list for the purpose of our conversation. It started off as a list, and you've seen how, oh, a list can be altered. It's the normal person at the store there that has a good relationship, and perhaps I have autonomy. Or if there's no powder detergent, you could buy liquid soap. That is a list. But where that autonomy is not granted and there's no very good prior relationship, then the list is now a tuple. It can't be altered. It has to go back the same way it came, okay? Because it can't be altered. It's immutable. That's a tuple. Now the dictionary, it comes with keys, it comes with labels. So how much is the meat? We're basically saying on that list there, think of the list as, oh, on that schedule, on the table of content, what is on chapter 4? So on this dictionary, what is the value for name, right? What's the value for name? So I just say, oh, name. Yes, I have name. So what's the value for name? The name there is Belema. What's the code, right? The value for the code. You can see it here, and it's the same thing here. Okay, so this is just for first view on data types, inbuilt data types in Python language. I want you to read up on sets, and where you have questions, please do not hesitate to fall back. In our next discourse, we're going to look at conditional statements, and then we're going to get into loops and functions. Okay, thanks for sticking around, and I'll see you in the next section. Bye for now.